California has to prepare because the most feared volcano is about to spew its contents. Scientists have warned about the recently discovered signs of volcanoes about to erupt, and it turns out we underestimated these warnings. One of these warnings was about the Long Valley caldera, and a recent analysis has just confirmed that this volcano's impending disaster will trigger a new period of the Ice Age. How did scientists make this discovery? Would this truly be the end of the world as we know it? Join us as we explore how scientists warn that a California volcano is ready to blow and Long Valley could trigger a new ice age. A huge bowl-shaped crater in the Earth is situated in eastern California, approximately 20 miles south of Mono Lake. This huge crater is known as the Long Valley caldera, and it was created due to the collapse of a magma chamber that resulted from a massive eruption 760,000 years ago. To date, the Long Valley caldera significantly remains a hotbed of volcanic activity. It is so big and powerful that when an eruption of a much smaller magnitude happens, it can affect regions as far away as Nevada, Sacramento, and Reno. And if the Long Valley caldera can send its wrath over to faraway regions, imagine what would happen and the damage it would cause to areas closer to it. A perfect example of such a region is the busy resort town of Mammoth Lake, situated within the caldera. There are other small towns in the area as well, and enough is not being said about the potential dangers they're about to face. A colossal eruption coming from the Long Valley caldera can affect a huge part of the United States of America, and that's not all. It leaves a huge gift of ejected toxic ash scattered around the area. The eruption that created the Long Valley caldera covered 2,200 square kilometers with hot volcanic material. Scary, right? And that same volcano is about to erupt again, but with a higher magnitude that can, in fact, trigger a new ice age. This is why scientists are cautious about this particular volcano as they monitor every activity coming from the Long Valley caldera to prepare ahead of an impending disaster. And now the huge volcano has shown signs that it's about to erupt, and to be honest, we are not ready for the disaster it will be bringing along. News about the impending danger started when scientists and geologists and people in the area began to experience a flow of tiny earthquakes in the areas surrounding the Long Valley caldera. This strange phenomenon immediately sparked fears in the minds of scientists. They knew that this massive ancient volcano had not erupted in hundreds of thousands of years, and it was suddenly beginning to give signs. At that point, they knew this eruption would be so powerful it could block out the sun and cause a new ice age. Right after warnings were issued to the public, the United States Geological Survey confirmed the news as it designated Long Valley caldera's threat potential as very high. For a body that watches volcanoes and earthquakes around the world, it is sure that millions, if not billions of people would almost certainly lose their lives if the volcano erupts. But of course, nobody saw magma seeping out of a crack or smoke coming out of the top. Scientists knew that danger abounded when over 150 earthquakes ensued, with at least one of them having a magnitude of 3.9. Most of these little earthquakes happened in Mammoth Lakes, the closest town to the caldera, and that was scary enough. Even conspiracy theorists like Steve Quayle talked about the situation as he talked about the phenomenon, affirming that the huge number of these earthquakes are turning into hazardous indicators of a pending volcanic eruption. For a supervolcano that had its last mega eruption 760,000 years ago and its most recent eruption 16 to 17,000 years ago, one might think it is no longer active. However, the United States Geological Survey still considered the Long Valley caldera area volatile, so they monitored it closely. Now, with the advent of these new and major earthquakes, it clearly shows that the volcano is very active, and gladly the USGS was able to make the quick discovery. Researchers and geophysicists like David Shelley from the USGS warned that the high consequences of another massive eruption should not be ignored. Yet there is nothing experts would be able to do about this impending supervolcano once it blows. If they were not able to do anything about this supervolcano, then how did they know what caused the series of earthquakes that led to the eruption warning? Well, according to research shown at the Seismological Society of America annual meeting, it was discovered that a spring surge of meltwater seeping through vertically tilted rock layers was responsible for the series of earthquakes that happened. This unexpected event led a researcher from USGS, Emily Montgomery Brown, and her colleagues to review the seismic and water records in the region for the past 33 years. Their analysis discovered that shallow seismicity rates were over 35 times higher during very wet periods compared to dry periods. Although scientists and researchers have always connected earthquakes to heavy rainfall or heavy runoff, before this the proof connecting the two has been somewhat weak or vague. Montgomery Brown talked about this in a statement where she said, "In the Long Valley caldera case, we're seeing a phenomenal correlation between the seismicity and the stream discharge, and we're seeing about 37 times the number of earthquakes during the wet season as during the dry season. As meltwater refueled the groundwater in this dry area, it altered the pore pressure in the rocks lying 1 to 3 kilometers below the ground surface, and as a result triggered small earthquakes. The shallow nature of the earthquakes alongside their bizarre distribution helped Montgomery Brown and her team discover that they were caused by seeping water and not volcanic processes related to the Long Valley caldera." In locating the earthquakes, Montgomery Brown's USGS colleague Dave Shelley discovered that the quakes were actually propagating deeper down from the surface. In other swarms around volcanic areas such as Yellowstone National Park, the earthquakes tend to start in a deeper seismic zone, about 6 to 8 kilometers deep, and often move upward toward the surface. Detailed geological maps of the swarm area to the south of Long Valley caldera depict steeply dipping, nearly vertical rock layers that act like a fast conduit for meltwater. The runoff may not be reactivating a particular fault, Montgomery Brown says, but instead may be infiltrating these rock layers and triggering small earthquakes there. The researchers didn't see the same correlation between meltwater runoff and seismic rates in other areas around the Long Valley caldera. It's only in these areas where we see the highly dipping strata, she says. But as far as she and her colleagues can tell, these shallow earthquakes stay shallow and do not propagate deep enough to trigger activity on deeper faults in the area. Montgomery Brown has been studying seismic signals and monitoring ground deformation at Long Valley caldera to keep track of volcanic activity and the movement of magma. Deformation caused by heavy snowmelt in the mountains creates seasonal signals in her data. Usually I'm trying to get rid of that signal so I can see the volcanic deformation happening. When the 2017 earthquake swarm, one of the biggest in a long time in the area, happened on the caldera's edge, she and her colleagues have been discussing whether volcanic activity caused it. People were starting to feel the earthquakes, and we were wondering if we needed to issue some kind of statement regarding how the volcano was behaving. But as she was giving a new manager a tour of a router closet at their offices, she ended up talking with Mammoth Community Water District managers who share the office space. She says as they spoke of the spring runoff flooding, it just kind of clicked in our understanding how the runoff and the swarm might be linked. Still, talking about the volcanic eruption and informing the public about it might be a problem because an earlier announcement about the Long Valley caldera's eruption had been made and nothing happened. Local businessmen are still angry at geologists for sending out the earlier warning. In fact, they say they would instead take their chances with a restless volcano than yield to fears that break the economy. This widespread attitude is now haunting state and local disaster officials who, working closely with federal geologists, are trying to create a new warning system for volcanic hazards in the area. The system that twice led to public warnings about volcanic activity in the early 1980s was dropped in 1983, and nobody wanted to be the person that raised a false alarm. "We have not been able to decide when to alert the public," said Dr. Richard Andrews, Chief Deputy Director of the Earthquake and Volcano Program at the California Office of Emergency Services. "Routine warnings about the sort of volcanic activity that is happening now," he said, "can scare away tourists. But if geologists felt that an eruption was imminent," he said, "the public would have to be told of the danger and evacuate. It's going to be a tough call," said Dr. Andrews. "We don't want to cry wolf." They cried wolf earlier in Mammoth Lakes, and it didn't work well. Mammoth Lakes is a 4-square-mile resort village with 5,500 year-round residents and is well known for its nearby ski slopes, hiking and biking trails, ice-cold lakes, hot springs, and extraordinary geologic features. Among them is the Long Valley caldera, the oval mouth of a collapsed volcano that is 90 miles long by 9 miles wide at the foot of the mountains rising behind the village. It is this caldera or giant volcanic crater that is now showing renewed signs of life. Volcanic activity has persisted in the area for hundreds of thousands of years, said Dr. Hill, but this is the first time modern geologists have been around to watch events unfold. Things started to shape up with a devastating alert in 1980 when 4 earthquakes that measured 6 on the Richter scale happened. Geologists were surprised by this phenomenon, so they conducted some research which discovered that the lava dome thought to underlie the caldera had risen by 10 inches between late 1979 and early 1980. And there were a series of small earthquakes through 1982 as the dome grew more inches. On May 27, 1982, federal geologists issued a notice of potential volcanic hazard, the lowest alert level in the system then used. The message was issued on a Friday afternoon before a local weekend festival, said Dr. Andrews, but it had an immediate impact. Tourists stayed home and the local economy collapsed. Housing prices dropped 40% overnight. Over the next few years, dozens of businesses closed, new shopping centers stood empty, and townspeople had to seek jobs elsewhere. And public anxiety was kept high in early 1983 by 2 magnitude 5 earthquakes, a continuing swarm of more minor earthquakes, and new measurements showing the dome had risen another 3 inches. Federal geologists considered issuing a volcano watch, its second and more severe alert level, telling people to prepare for disaster but held off to see what would happen. The third level, a volcano warning, would have meant an eruption was thought to be imminent. But after mid-1983, nothing happened. Tourists, homebuyers, and new businesses did not regain confidence in the town, though, until 1986, and the economy has been recovering steadily since then. So when the caldera began showing new signs of life in the spring of 1989, businessmen were shaken and geologists were cautious. Scientists noted thousands of small earthquakes throughout that summer and found that the dome had risen another 3 inches. And then after a period of quiet, the small earthquakes, often hundreds a day, started again in December and have continued off and on through to the present. The dome had probably lifted another 2 inches, showing that the magma was moving again. But aside from a few articles in the local newspaper and one town meeting a year earlier about the series of incidents, geologists did not say much to the public about the current activity. There has been no official notice of volcanic activity. And there are good reasons to stay quiet for now, said Dr. Hill. In 1983, geologists had few scientific instruments in the Long Valley region, but today there are at least 40 seismic stations and a network of other instruments that give a wealth of data on the caldera's behavior. The emerging picture, said Dr. Hill, is potentially menacing, but not in the near future. Under the caldera are several magma chambers capable of creating relatively severe volcanic eruptions, he said, but not on the scale of 700,000 years ago. Researchers approximate that the caldera would have to rise another 1.5 to 3 feet before the overlying rock might give way to the pressures below. And geologists say they are encouraged in their decision to not warn the public, at least not yet, because of the way 2 other active calderas have behaved in recent years. A caldera near Naples, Italy, rose by 9 feet in 2 bursts of activity over the last decade and did not erupt. Also, a caldera in Papua New Guinea rose by more than 6 feet in the early 1980s and nothing happened as well. The Long Valley caldera may be doing what it has typically been doing for thousands of years, said Vern McLean, a geologist with the National Forest Service in the nearby town of Bishop. He said it might roil underground or produce small volcanic eruptions that squeeze out magma like toothpaste. Or he acknowledged it could blow up, causing widespread damage and loss of life. However, scientists think they will get strong warnings in the days or weeks before a violent eruption occurs. These include significant earthquakes accompanied by ground tilting, changes in magnetic fields, earth tremors that exhibit harmonic frequencies, and other signs indicating that the magma is headed for the surface. In the meantime, geologists and state and local officials have been working out a new warning system for the public. Instead of 3 levels, the proposed method has 5 alert levels based on the intensity of geological events and specific combinations of events. For example, swarms of small earthquakes might elicit a low-level alert, but the swarms accompanied by rapid ground tilting or steam venting could produce a higher alert level. Dr. Andrews said the first 3 or 4 levels would not be made public. The information would be used by geologists and disaster officials for internal readiness, he said. In the chain of responsibility, geologists alert state officials who then decide when to alert local sheriffs. Martin Strelnick, the Mono County sheriff whose district includes Long Valley, said he does not know when the public will be told about volcanic threats. If it gets to the hazard stage, the public has a right to know, he said. But who has the expertise to say a volcano will or will not do something? It's a scientific guessing game. Still, volcanic threats are synonymous with California. California is an earthquake country. According to the first update of the federal government's volcano threat assessment, in over 10 decades, 3 of California's volcanoes are regarded to be a very high threat, alongside 15 others nationwide. Mount Shasta in Siskiyou County, the Larson Volcanic Center in Shasta County, and the Long Valley caldera that comprises the Mammoth Lakes area in Mono County remain in the highest risk category as defined by the U.S. Geological Survey. The USGS list of the 18 very high-threat volcanoes remains the same as the last one updated in 2005. They comprise 2 such volcanoes on Hawaii's Big Island. One is Kilauea, which underwent a new eruption earlier this year and sent oozing lava to destroy hundreds of homes, and Mauna Loa, known widely as the largest active volcano on the planet. Another 4 are in Oregon, including Mount Hood and Crater Lake, and 4 in Washington state, including Mount Rainier and Mount St. Helens, which underwent a deadly eruption in 1980 and is the most active volcano in the Pacific Northwest. The USGS said that explosions and volcanic activity under snow and ice can send hazardous projectiles long distances into populated areas along the west coast. The agency said 5 are in Alaska, near populated areas and economic infrastructure, or below busy air traffic corridors. There have been 10 eruptions in California over the last 1,000 years. In any given year, the chance of a significant volcanic eruption in the state is about the same as the risk of a significant earthquake on the San Andreas Fault. The majority of California's most scenic wilderness spots are threatened by volcanic activity. Over 190,000 Californians live within a volcano hazard zone. Among them are people who reside or work in the Long Valley region, home to Mammoth Lakes, a favorite destination of skiers from Southern California, and areas in the shadow of Mount Shasta, such as the towns of Mount Shasta and Weed. Those cities are near each other enough to the volcanoes that they may not be safe in the next eruption. Volcanoes in Lassen, Shasta, and Long Valley areas can help produce pyroclastic flows or surges when they erupt, fast-moving flows of hot ash, rock, and gas sweeping down the sides of mountains of the type that killed 57 people when Mount St. Helens erupted in 1980. How the Mount St. Helens eruption unfolded caught scientists by surprise. There were signs that magma was moving underneath Mount St. Helens months before the eruption, but instead, from the top, the eruption occurred from the side of the volcano, sending magma pressurized with gas erupting out horizontally instead of vertically. And because the previous direction of the pyroclastic flow was aimed horizontally, it traveled much farther on land from the summit than had been anticipated and killed people beyond the evacuation zone. Such pyroclastic flows are so hot they will scar flesh and sear lungs. Too much ash can also make it hard for one to breathe. Those who had died generally had been within 15 miles of the volcano. Most higher-risk volcanoes are far from California's largest cities. Some of them produce heat that's used to create electricity in what are the world's most productive geothermal power plants, such as the Salton Buttes 160 miles southeast of Los Angeles and the Clear Lake Volcanic Field 85 miles north of San Francisco that powers the Geyser Steam Field. Those areas are considered to be in the second highest risk category, as is Medicine Lake Volcano in Modoc and Siskiyou counties. But volcanic eruptions could have lasting repercussions that affect all of California. Volcanic ash could bring down jetliners and disrupt hundreds of flights moving through Northern California or the Mammoth Mountain area daily. In 2010, the eruption of a volcano in Iceland forced the cancellation of 100,000 flights in a week. And volcanic ash, when wet, is conductive and can pause or be disturbed by high-voltage lines that supply electricity to millions of California homes. Ash could disrupt travel on Interstate 5, the main route between California and Oregon, masking windshields and making roads slippery, even impassable. And it could contaminate water supplies to much of the state. California's largest reservoirs are close to the Shasta and Larson volcanoes. If there's any relevant information, significant volcanic activity is usually brought by warning signs. Scientists have become much better at forecasting major events before they occur, enabling authorities to make sound warnings to limit the chance of deaths. California's volcanoes were more prolific in prehistoric times. About 760,000 years ago, a supereruption happened to what is now known as the Long Valley caldera, erupting an astonishing 140 cubic miles of magma, covering much of east-central California in glowing hot ash and blowing ash as far away as present-day Nebraska. And the Yellowstone volcanic system in Wyoming underwent its own supereruption 640,000 years ago, sending out 240 cubic miles of magma and dumping ash as far away as California, Louisiana, and Iowa. Mount St. Helens, by contrast, erupted only 0.05 cubic miles of material. USGS scientists say there is no sign of enough magma underneath Yellowstone or Long Valley to cause another supereruption. About a century ago, Larsen Peak underwent years of volcanic activity. Then, in one of the most significant events, about 103 years ago, Larsen Peak created a gigantic mushroom cloud that reached an altitude of 30,000 feet. It could be seen as far away as Eureka and Sacramento and sent volcanic ash up to 280 miles away, reaching Elko, Nevada. It was the first volcanic eruption in the contiguous 48 states since the founding of the United States, and the last until Mount St. Helens erupted on May 18, 1980. A couple of America's cities are close to volcanoes. Hilo, Hawaii is on the flanks of Mauna Loa. In Arizona, Flagstaff is the edge of an extensive field of more than 600 volcanic vents centered around San Francisco Mountain. Now, do you think the Long Valley caldera is about to blow, or is this going to be a false alarm as it was in the 1980s? Let us know your thoughts in the comments section below.